Today in the physics lab, we're going to look at the blind spot. So your eye has a blind spot where the optic nerve bundles the information from your retina and channels it back into your brain. Each eye has a blind spot, and they're in about the same place. So to demonstrate that, first we're going to do it, physically with you there on the camera, and then I'm going to do it, demonstrate it with a model. To demonstrate it here on the camera, all I have to do is pull this up, and essentially these instructions are saying you have the plus sign and you have the dot. So we're going to focus on the plus sign, and so what you have to do is cover up, either close your eyes or cover your left eye, and focus your right eye on the plus sign. So if you're far enough away, you'll be able to see the dot in your peripheral vision, but just focus right here. Then as you get closer, at some point, it's going to disappear. So for me, it's right here. Like I can't see that, if I turn my eye and look at it, oh yeah, I see that. But if I'm focused on the plus sign, I can't see it. But then if I get close enough, it reappears. And you should be able to convince yourself of that now. So go ahead and pause this video and kind of go in and out, only focus on this. At some point, that dot will disappear. That should convince you that you have a blind spot. Once you've done that, hopefully you paused the video and did that, you should convince yourself that you have a blind spot. It occurs usually about when the screen or this image is about 30 centimeters from your face, but it kind of depends on, exactly how the limit is and all that stuff. So let's go ahead and look at our model here of what's going on. So if we look at this, I've got the model set up here. Might be a little bit too close. So we're not going to look at this setup here, not with the plus sign and this. We're actually going to scroll down a little bit, and on the sheet you can see that we've got the plus sign and we've got the dot, but the dot now has a crossbar of its own on it to help highlight the dot when it's in the blind spot. If you do this with, you can zoom in and check your blind spot on this one. It's going to be a much harder time because what happens, when you're looking at your blind spot, the brain can fill in, and so that's what happened when you were in with the blind spot the first time. Your brain just filled in with what was around it. In that case, it filled in white. In this case, if you do the blind spot test with the cross, you'll be able to see that your brain will probably fill in a black dot there in the middle. Your brain's pretty good at guessing what is there. So here on our model, we can see that we have everything set up. So here I've got this image being projected here, and you can see that I've got the dot on one side and I've got the cross here. And remember, our model actually has a little hole in there for the blind spot. So what I'm going to do now is, that's my blind spot. If you're at the right distance, here I'm just simply turning it, but you can see that, obviously if it's there, you're not going to be able to see anything. And so that's literally what's happening, is that part of your image always falls into that spot. So now there's a couple of reasons that you don't notice this in real life. The first one is that it's only at a certain distance. You can almost imagine this cylinder almost coming from your eyes on both sides. But the problem is, the first key to solving it, the reason why it's not an issue, is you have two eyes. So anything that this eye can see, your brain can fill in that information over here, and vice versa. Stuff that's blocked over here can be filled in by your right eye. So that's the first key. That's why you have to close your eyes in order to see your blind spot. And the second thing is your brain just is pretty good at guessing, fills in with what's around it. So that's the blind spot.